capacitor charging and discharging, and we saw that during discharging, this was the formula here, written a little badly, written a little better here, but the formula is Q is equal to Q naught e to the minus T on RC, right? That shows how a capacitor discharges over time, and the graph looks like what? What the graph look like? Nice, the graph look like this. Okay, right. I was we were taking a look at a quantity that represents RC. What's the name of it? What's the name again? RC was equal to something called time constant, right? And the symbol was tau, right? Right. Tau. RC. Yeah, go from my vendor. Right?
It's still a good shot, right?
Man, you can make one
Yes.
don't about that. Right? What is so RC is called time constant and is defined as the time taken to reach 1 on E of the maximum value. Right? So the time taken, what's going on here? So the time taken to go to 1 on E of the original of the maximum value, that's called a time constant, and the SI unit is seconds, right? So that's where we stopped last day, and we did a couple of questions, but I wanted to just go over that a little bit. Right, after we did capacitance in series and parallel. There's one more thing that we have to consider, right? How do we determine the energy stored by a capacitor? All right? Yeah. How do we determine the energy stored by a capacitor? Right. So therefore, if we take a look at this here, the charge in the capacitor is directly proportional to the PDF process. Right? So the charge of the capacitor is directly proportional to the PD process, and the graph of PD versus charge is therefore a straight line through the origin, right? And I'll build up from here. So watch this here. So if you look here, right? If I gave you a graph, right? I gave you a graph of charge versus voltage, right? And you get a specific line. What does the specific line give you? Right? The gradient of that line is what? The gradient of that line is C. Right. Is charge, which is Q on voltage. And we know that charge on voltage, check this now. Charge on voltage, we know that charge on voltage is capacitance. So if I give you a charge versus voltage graph, the gradient is your capacitance. And the area under this graph, this entire area here, that area is your work done. Okay, work done or energy stored. That's okay. So the work done or the energy stored of a fully discharged capacitor is a half Q by. Okay. So if I ask you to find energy stored, is QB. Right? You also where they get the half from?
Yeah.
It's a triangle, right?
Yes.
It's a triangle.
Well, when it
half
comes to this,
base by height. Sorry?
which document is this?
The big one. The one on the whole module. The one on the whole module. Huh? Oh, Q1B. Q1. Charge of voltage. All right. So to find the capacitance, to find the energy stored, right, in a capacitor, from the graph is the area, right? So make a note of that. From the graph is the area, right? But the general formula will be W is equal to half Q. All right. If you look at the graph there, you can see where the formula came from, right? There's a next proof as well using integration. You all can see how we can bring in integration here. Here under the graph, right? But I wouldn't do that version. I'll do the simple version. Huh? Integration, no. You get it? I don't understand this one. Right? So the area under the graph for charge versus voltage graph, that area is your energy stored. Well, just do my favor, that's plain name here. I don't have your rule. That's a quick. So first unit one, that's the
I see how you want to say
right, and here we have right here we have, you will see energy loss. You'll recognize energy stored and lost looking like the same formula.
Yes.
Right. Half, right? Okay, that's yeah. Half stored, half the first part of it. Yes, you just make sure you put in the side up, right? Right, and there you have two other versions. Right? W is equal to half CB squared, or W is equal to Q1C squared, right? Okay, so before we attempt any past papers, we are going to, right? So I'll make a small summary first, right? We're gonna do a small summary so that's easy for us to find things as we go. Yeah.
Yes. So where with it?
No, I'll take it off now. No, I'm gonna do a summary now. I'm gonna do a summary of things that we need to remember, right?
Yeah.
All right, so do my little favor now. Let's take a 5 minutes and see if we can compile a small summary of all the things that we'll need to answer questions. Right, start from here. Capacitance is what? Capacitance is what? Q1V, right? We could also find capacitance based on the actual component. So it's what? Yeah, the thing, the epsilon thing. Epsilon naught by over D. What's in? Are you okay with that? Yeah. And then we have capacitance in series. We have capacitance in series. 1 on C is 1 on C1 plus 1 on C2. Parallel, C is equal to C1 plus C2. Okay, and then we have for charging and discharging, right? So during charging, yeah, this is something we have all the equations that we need, and then we're going to put them together, right? Charging, discharging, and then charging, because we're going to practice some past papers today. Try that, please. Right, so you have that, and then we're gonna try to take a look at questions, right? No, I want you to. Yeah, just put it forward for charging and then charge it. And remember to make sure and tell them what tau is, right? Yep, what is time constant? Right, cool. Ready? Ready? Right, let's start with some multiple choice. I don't have the years, right? But let's start with some multiple choice. Then warm up and then go to some paper tools, right? Vanaya, what do you think about number one there? Yeah, Vanaya, what do you think? A, B, C, or D? Should we play to it? When I come to the can't say no. Right, the guys two in parallel, right? So both of these formula, both of these things are correct. So I just zoom in there, right?
I think it's.
What else? No, I was never gonna add them. I'm coming down in order, right? So B went first. Right, C1 and C2 is parallel, right? Would A be the answer?
No.
No, alright. We just shoot them away thing. Yeah, so you said C1. Why? Why Arian? Why? Why right? Right, the potential across each capacitor is the same, is that true? Potential is the same parallel?
Potential voltage splits up.
In parallel. What happens to right? So is the answer C or D?
D.
D. Why is the answer not C, Arian?
Because due to the resistance.
What? How you find energy stored? A half Q by B. So is B the same? Yes, just say B is the same. But what about Q?
Charge will be different.
Charge will split up, so therefore they won't have the same energy stored. That's okay, Sean? Follow why the answer is C? Yes, so you agree with C, right? So you're not paying attention, the answer is D.
Wait for you.
Yes, the answer is door. Right?
For you.
Yes, the answer is door. Because the potential difference is the same, but the work done is not the same because the charge will change. Okay? So the answer is door. Make a note of that, please. For some other. Actually make it job at the table. Next one. So. But only I don't know why the picture come up like that. Sorry. To the corner there. Anthony, the one on top is yours. The one underneath is yours with the fan shoe. Oh yeah, real easy. Why? Huh? Hurry up. Nikila, hurry up. Book it out, Nikila. No, sorry.
And see the cards.
Huh? A. No, we just say, just wait, just see. You get? Which one, boy?
D.
Dog. That's not.
Wait, again.
Yeah, we're working it out. By the way, what's the formula we use to find the energy stored? We have voltage and we have capacitance.
I get D.
What's the formula we use?
Is because I have cubic.
A half.
Cubic.
Oh, you don't have Q?
Yeah, C.
We have C.
I have C.
That's not the formula I get for you. Check the formula sheet. E is equal to what, Sean?
Let me see that again.
Wait, so we have C.
Yeah, we have C. Well, you can find but you can just use a half CV squared. I give it up. So work it out now, please. Right, 100 by 10 to the minus 6 by 200 squared. How much?
Yeah, think it's A. B. I get 2. Yeah, B against.
And you work on the whole thing, right? With these values, right?
Yeah, 2.
Anybody get P online? Anybody online pay attention? Let me see. Who pay attention? Anthony, hurry up. Let me see, hurry up. Hurry up. What you got?
The axon is.
Hurry up.
Axon.
All right. You got 2? Huh? 2? You're not paying attention. Right now, make a notes. Your mother to watch. Right, next one. That's easy. Number 1 is what? 1 farad is what? C, right? C, very good. Yeah, charge with what book here?
One charge by one.
There's one more somewhere here. Try this one here. Next one here, let me check somebody down in the back. What's the diagram? Let's go with Timothy. What's going on here? Charging us this charger. Right? So what's the answer here? Which one there could work?
I think once you take a piece of no, it's not okay.
Timothy, what do you think? Huh? Dog?
Yeah.
Well, why is this not boy? Huh? Because boy have a minus and why is not apple? Because that's the wrong formula for Q, right? Q naught, right? Okay, Q naught will be C by B. Okay, so that is dog. Right, call it this is I can't put this now. Take the sheet next time, right? Right, and multiple choice. Ooh, I like this one. Yeah. Oh. Right, watch this here. What is called the A and the dielectric deviation behind. All right, I'm going to call about last thing. All right. No, sing it to one in the back. Because what is that? This is not for me. Let's go with Maharaj. Maharaj, what is called that thing in the middle there? What is called the thing in the middle of the plate? No, what's the next name for it? Huh? Huh? It never key in it, but it's not good. It's called a dielectric, right? So the thing in the middle here is dielectric. Okay? Look at the formula. Look at it there and take a little read. Work it out, please, the fan shoe. Huh?
So I was asking temperatures today. So I. You can ask your son, I like to look up athletic price for
Huh?
Really? Yeah.
Anything better on this?
I thought it was absolutely. City one really?
Alright.
And when it got to free seat.
Huh? Figure one shows the parallel plate capacitor with the space between the plates filled with air. Figure two shows the same capacitor with a space filled with dielectric permittivity is twice that of A. What is C2 to C1? Without looking at the answer. What it is Maharaj? I have, huh? Look at the formula. Look at the formula there. The second diagram is twice as good. Well, twice as permeable. I will ask if I can get it. Yeah. 2 to 1, right? 2 to 1. So the answer is? The answer is C. Alright, so that is the summary that everybody should have, right? So now we're going into paper 2. The same thing what they have. Right? So we are going into past papers, right? Just make an adjustment to the formula, the second formula, right?
So for discharge, you have, I know that.
Starting with So it's the same Q formula, it's just charging and discharging is a little bit different.
So I have D.
What is bar one?
I have D equals Q.
As Q is equal to Q naught.
So that's Q.
Nah, D.
Hey.
Just look at that D.
That's a
Yeah,
D.
D is a Q.
That's a D.
Because you did this, it's like.
That is a Q.
That's why I airdrop.
I have my airdrop.
If that sounds so good.
I airdrop it to my car.
Everybody.
I just.
Well, it's ridiculous.
Okay, see.
No, I just read it, so just. Yeah, my outfit here. Look, it's so colors. No, yeah, wow. You look
Alright, let's go past paper time, well, paper two time. Let's put this in. But, I recognize that you all do remember this, so I just come on. Yeah. The form was so important. Yeah. Right, there's just one thing I recognize that you all do remember. If you have voltage and current, right? If you have voltage and current in series and parallel. And this seen now because you all do remember this. Voltage in series is what, Shirish? Voltage in series is as what's your name again? Nadia. Melia. Nadia. Voltage in series is what? Same was splitter. Huh? Yeah. In series and in parallel. And since we get two right, okay, last two right, current in series. Alright. So just make a note of that because some of you also remember it, right? And let's jump into the question for one time. Well, let's go to right?
I have.
Sure, I got it. Funny question. I don't grab that. Hey, sorry, I'm not paying on person. We'll be here for next competition.
Alright, let's go. That basic common stuff, you should know that. Going around. You can't see on the board, but you're seeing something white. Okay, so let's begin here. Part 2 is defined CE, right? Try part 1 first. Right? I know you're not seeing it, but part two is to find CA. Oh yeah, try that please. Try that please. Find VA and then find CA. Oh yeah, oh yeah, no, yeah.
How we doing this? Yeah.
Because I
Nobody switching over money. Get a good time. Go to CID. We don't have any time. Right. Wait, but child, you see it? Yeah, just one. Wait, that's serious. Yeah, child, you see when that's serious, right? Right, so you said yeah, that's what. Yes.
You just like pick it up and just let it go. Yeah. Yeah, it might be fun.
You should make this be like, that's right.
Yes, it'll be. Oh, 92nd about CE. I didn't know that. Yeah. Yeah, I guess we get with the fun.
Right, what we're going to need, those are the rules there, right? Ready? Finish your thing? Right. So let's check out what they got here. So first thing first, figure one shows a circuit including two capacitors where CB is 60. So you recognize that CB and CI and what? CB and CI and what, Tibish? Right? CA and CB is in series. Right? We know voltage splits up and we know that current is the same, right? So first thing first, we want, right? First thing first, they want us to find VA. So for me to find VA, right? I know that the total voltage is, that's all. Total voltage is 300. So it means that VA is 300 minus 100, which is 200 volts. That's all. Okay. And then they want us to find CA. We know that capacitance is equal to charge over voltage. We know the voltage, huh? That's 200. But we don't know the charge. Right. So we can get charge from right here. Right? So just rearranging the formula, and that would be capacitance. Capacitance by voltage. Huh? 6 by 10 to the right? 6 by 10 to the minus 3. And then when you divide it, what you got? 3
50 microfarads.
50 or 3. Right? So if you make 30 microfarads, technically you can look at the voltage, you recognize it's half, right? Well, you can't see. All right, next box. Okay, go up on that.
Yeah.
Lily, I know looking at those.
Well, then we can like, we have that.
All right, next part. That was it. I have one more part. Let's go again. Oh, this one here, they give you the graph, right? They give you the graph. Take a switch and send in group now. Take a picture and send in the group. Right, this is 12. Take a picture and send in the group, right? But without even reading it. Because this is charging or discharging or capacitance. Charging or discharging. Right, but just look at the graph, it's long. Right, but I'll change it a little bit. Yeah, the graph is long, well, so I take a picture and send it to you. Right, so that is the formula for discharging, right? Make a note of it. Well, you have seen those actions, sorry.
Yes.
Check on the groups, like, you want to have a check on the group.
B exponential is
Right, so look at the graph, right? Look at the graph they plot then, next Nikolai. Nikolai, look at the graph there. What they plot? No, what they plot, X and Y. Right? They plot ln B versus time, right? And we know the formula is B is equal to V naught E T on RC. So, guess what they're going to ask in, they're going to ask to find no. They're going to ask what ingredient represent. Right? Eden, what are you going to do, right?
The gradient represents exponential.
No, there is something that we have to do. Look at the graph. Oh, no, I just draw a random thing, sorry. Let me show you what you have. Yeah. Look at this, right? So the graph is ln V versus T, and now they want us to determine what the gradient is. What we gonna do?
So y is equal to mx, you can use that.
Right. We had to put it in the form y is mx plus c. So how do I get ln in here?
Apply ln.
Right. Do my favor now. Take ln on both sides and linearize it. Right? Take ln on both sides and linearize.
So that is equal to small like on the So when we done integration.
Well, technically.
Oh, you want the chat? So I can just tell it didn't give it to me based on after academics. They didn't give it to me.
I don't know that gonna make it right.
Definitely.
So looking at the C value,
Pardon me?
the value like cut the graph, right? That will be the C value.
The value on top of the graph.
When you cut your axis, that will be the C value.
Well, I'm doing now. That's not what you're saying. Should we tell linearize that?
So that's like a full right now. I think it's like to.
All right.
Yeah, it's it replies to me that it is not.
Right, so when you take ln, you'll get ln V is equal to ln V naught e to the minus t on RC. This will be ln V is equal to ln V naught. Remember, this is multiplication. So we can add ln e to the minus t on RC. All right. So remember, multiplication means addition, right? And now I could write ln V, right? I could remember, I could bring the power down, right? So I'll get ln V naught minus t over RC by ln E. So I bring this down, right? And ln E is, so I have ln V is equal to minus 1 on RC by t. I just separate this plus ln V naught. Right? So I just separate this to bring it t out. Why do that, Ariane? Why did I bring it t out?
Because of x.
Right, because this is my y, this is my gradient, this is my x, and this is my y-intercept. Okay? So for a graph like this, the gradient represents minus 1 on RC. Okay? Right. Ready? Let's go back to the graph now.
But my lad said that's gonna say, yeah.
So did you get back for the
So we do.
Say exactly.
Right? Here's the graph. Here is the graph. They want you to calculate gradient and hence find time constant. Go ahead. Let's find time constant again. Fire time constant is what? That's the definition, but the formula is RC, right? Go ahead. Do you think find gradient? Well, yeah. Pay attention to the unit, right? Seconds and volts. But sometimes in these questions, things is being like micro and 10 to the power, right? Look out for that in the axes, right? This one's straightforward. Go ahead. Find the gradient and then find time constant.
Three. We do have multiple choice.
Well, we do like two multiple.
They put that last thing as well. I don't mean it to be thanks.
Did you get a refund?
Huh? Finish. Find the gradient and then find.
So you can't give us like equations.
No, you can't. Laugh not my head. One go down the way.
So you know the like the way of your camera is like
Everything
similar to the slowly ground.
I slope a little bit. That's look sharp one.
One by the way, but
There.
Right, we got the gradient, quick.
Where's RC?
No, they want you to get, thing first. Find time constant.
So if you find one of RC, it's
Singing, working it out. By watching Marat thing there.
Ingredients.
Huh?
Ingredients.
No, one. Other than getting negative value.
yeah. Yeah.
Right, so the gradient is equal to. What you all said, one. 2.1, 2.2. Should have probably. I think she'll figure it out. 0.1, 2.2.
But this use a point in top, that's 4.2
Oh, I just use it, it's 2.2 and 1 plus. That one. So minus 0.5.
Yeah, so roll your points.
Yeah.
I get minus 121.
0.05.
That'll give it so.
I just use.
Oh, sure, that's 10 at the bottom here.
Yes, sir.
So I got minus 0.05. Yeah. Anybody else got that?
Yeah, I guess 0.047.
I will.
Ah.
0.55. 0.55. Online, any answers? Let's see if we can depend on online here. Tabisha? What you got for your gradients?
Yes.
Can I two was going on here in Tabisha? So you think 0.05?
One of our ICs equal to 0.05.
Ah, Tabisha gets the RAM group got 0.05 underneath. Ah, RAM group. All right, let's continue and find time constant.
One of our ICs.
Right, so minus 0.05 is equal to minus 1 on RC.
I don't know, I answered the same thing.
So RC,
So it's R.
R is resistance, C capacitance,
IC is equal to 20.
20.
20
Right, because the SI unit for time constant.
seconds.
All right, next one. Devanshu, come on, do this one. How we getting the unknown capacitance C? The value of the unknown C didn't give us R.
So I feel like any question, but you can talk now.
Yeah, something that's a bit, what's up, ours?
Let's say RS3.
All right. Nobody did, they gave me R. I think I cut off the first part, E and B. That's not, I'm gonna look for it here, I'll tell you that. That's the question. Oh, 1 second, tell them this bucket fine now.
What's the difference?
For now, use R as 1,000, right? Use R as 1,000 and then find C.
I got 1,000.
Yeah. I'll be back for you, give me 1 second. Oh, I'm finding part 3. The one that we did first was 2014. The one that we did first was 2014, and I now find part 3.
Oh, you just looked at it already.
All right, now found it. It's now 1,010 mega ohms. It's 10 mega ohms. And the capacitors connected in series. Okay, sorry about that, right? But the question is the two capacitors in series and the R value is 10 mega ohms. 2011. The one you're doing is 2011. Anthony, the one you're doing there is 2011. You gotta look at that, I can't find it. I know you're looking for it on your phone. Yeah. Question is 2011, yeah. Right, so use R as use R as 10 mega ohms. And then the two capacitors are in series. They want you to find the value of the unknown capacitor C. And then find EMF. Okay, so the two parts that we missing are these two here. Find the value of the unknown capacitor and the value of the EMF. All right, so remember the capacitors are in series, right? So what we got for C equivalent, that'll be 20.5, sorry, 20 divided by R. R is what I said? 10 mega. So 10 by 10 to the power of 10. So that would be 2 microfarads. That's okay? So now they set the two capacitors in series. They set the two capacitors in series, find the values for C. Right? So we know this. We know that the equivalent value, that's the total is 2 microfarads. One value is what? What's the first value again? Oh, 4.7. Right, sorry about that, yeah? Right, that's one stuck over. 4.7 is this. That's the part one top. So we should finish. Fine. Go ahead. So you want to find C. So that's what you want to find out. You work out this, find C. Oh yeah, work it out. Then you come on the board and finish it. Now fast. Work it out fast. How much y'all got? 3.48. I just asked na ganun yung bone now. Right, those who online, you can just take a look at the camera there. Right, so it will be equivalent is, since this series is 1 on equivalent, is equal to 1 on C1 plus 1 on C2. So that's 1 on 2 is equal to 1 on C plus 1 on 4.7. Right? Carry it across, you'll get 1 on C is 1 on 2. Right? And then what you get here? 27 on. So C is equal to 94 on 27, which is 3.48 microfarads. Okay? And you have one part, you want to find EMF. How are you doing that? How are you getting the EMF? In this formula here, in can't you? In that formula there, what is EMF? Yeah. In that formula there, what letter represents the EMF? V naught, right? That's the maximum voltage, right? Right? Remember the maximum voltage in the capacitor is the EMF? Well, remember that? Why was explaining the how it's charged? Go ahead, find V naught. Last thing, look, when you been doing nothing, you shouldn't be in no hurry to go nowhere. Right, the y-intercept, I am using it as 2.2. Right, so this here is the y-intercept, right? The y-intercept is that. Oh yeah, find V naught. Remember we said y-intercept, ln V naught is C. So ln V naught is 2.2. What's the inverse of ln again? E to the power. E to the power of 2.2, which is 9 point. If you use this value. Right? Yes. Alright, so that technically is the end of capacitance. We'll do a little hoot on electrostatics, and then we start electricity. But we can take it by no one here and they will try to actually try. Alright, so next day, remember we have no class next Friday. Next day we start electricity after the Kahoot, right? Huh?
Oh, yeah.